We're going to look at the grouping method of factoring polynomials, and this is what you look for whenever you have four terms like this. So you make sure that they're in normal order, where it's the highest exponent, then the next highest exponent, and then the next highest, and down to the lowest exponent. Alright, so for the variables, this of course that's x to the 1, and this is x to the 0, which we don't show because that's equal to 1. So the steps for doing this is that you cut it in half, and you take out the common factor for each half. So I'm going to look at these and see that there's no common factor for the numbers, but there is a common factor for the variables. And so I can set it up with the common factor, 13x cubed divided by x squared. Only one x will be left. Here when I divide by x squared, no x's are left. Over here I look, and there is no common factor, but there actually is. You can think of it as there's a 1 there. So we're going to say plus 1, 13x minus 8, because there's always a common factor of 1, actually. Notice that these two are the same. Now, in this kind of a case, that's really important. Let's take a slightly different example to explain what I'm going to here now. If I had x squared times z plus 1 times z, think about that. I have x squared times z and 1 times z. There's a common factor of z here. So I'm going to take a z out from this one, and there's going to be an x squared left. I'm going to take a z from this one, and I have a plus 1. So now I just took out this common factor of z. I like to put a line through my z's so that I don't get mixed up as 2's. I have to be careful that they're not 7's. Okay, but I'm taking z out of both of these, so z from that leaves me x squared, and that leaves me a 1, and I have a common factor of z. If I multiplied this back in, I'd get x squared times z and x squared, or z times 1 here. Well, this is a more complicated version of z, but that's all it is. This is x squared times this plus 1 times this. So we're going to take out a common factor of that. 3x minus 8 is a common factor, and what's left is x squared plus 1. That is the factored form of this. So what you do is you split it up, take out the common factor of them separately, and then take out the one that's the same as a common factor. If you multiply this back in to check it, 13x times x squared is 13x cubed. 13x plus 1 is 13x. Negative 8x squared there, and a negative 8 here. Oh, well, let's see. Oops, well, there is supposed to be an x squared. Oh, that's negative 8x squared here. So I forgot to include the square root. I have to put it in order, so I'm going to have to switch these. 13x cubed. This one should come next. And 13x minus an 8. This is standard form because of the fact that it's in order 3, 2, 1, and then 0. X to the 0 for that one. Okay, so that checks that this is the correct answer. So now that you've seen that, and you see the steps are to take out one common factor, take out another common factor, and then take this out as a common factor of the whole thing. Really 3 steps, and then a 4th step is to check it. Please do that now with this problem. Practice 10x cubed minus 25x squared plus 4x minus 10. Pause the video, do this problem, and then come back as soon as you're done, and I will show this in video time. In about 5 seconds I will start doing it. Alright, I'm going to draw a line down the middle between them. Looks to me like I can take, for 10 and 25, I take 5 out of both of those, and an x squared out of both, because this has an x squared in it, and that's what that has completely. So I'm going to have a 5x squared. That's going to leave me a 2 and an x from that one. Okay, 5 goes into 10 and one of the x's. And here, that's going to be a 5 and no x. Over here, I'm going to do the same thing. I'll look at these and see that I can divide both of these by a 2. So I'm going to have a plus 2. That 2 will come to it. And what's left is 2x here and minus a 5. And these two are the same, which allows me to take them out as a common factor. All right, 25, it's 2x minus 5. Getting ahead of myself too much there. And then these, if I take that out as a common factor, I have 5x squared left, and take that out from this one, I have a 2. Now, doesn't matter, this one could come first, doesn't matter which one, because this is a times b, or b times a if you want to call it that. Now, if I multiply it back, I get 10. In fact, let's do it. 2x times 5x is 10x squared. 2x times 2, that's 4x. And then I get negative 5 times 5x squared, negative 25x squared. Negative 5 times 2 is a negative 10. Oops, that's not 10x squared, it's 10x cubed. X and x makes an x, and x squared makes an x cubed. So I have 10x cubed, negative 25x squared, because that's the next highest exponent, plus 4x minus 10. And that is indeed what we started with here. This was the original problem, and that means this proves this is the correct factoring of it. Now let's do one where there is a negative factor. So what I'm going to do here is that negative there will change things. Let's do this as normal and you'll see what happens. So here it looks like I can do a 7 and an x squared. A 7 and an x squared. So I have a 7x squared. That's a 1, so it's just an x here. That's a 1. In fact, this whole thing's divided by that, so we get minus 1. Over here, I can take a 2 out, but here's the key thing. When this number is negative, you make it a negative number that you come out. So I'm going to divide both of these by a negative 2. So that means it's going to be a negative 2 here. The negatives make that positive, x, and a negative 1. If I didn't do it, I would have a problem, and here I'll show you why. Negative 2x plus 2. If I take out just a 2, I'm going to have a negative x plus a 1. X minus 1 and negative x plus 1 are not the same thing. I just can't, even if I switched it, I would have 1 minus x, which is not the same as x minus 1. So this is not the way to do it. You have to take the negative out whenever the third term is negative. You're going to have to divide by negative as well. By doing it, it allows these two to become the same, which means this is 7x squared times z minus 2 times z. Now I can take z out as a factor. That's a factor of this set of 4. And then I can put in parentheses the 7x squared and the minus 2. There we are. Oops, let's check it to be safe. Of course, x times 7x squared is 7x cubed. X times negative 2 is negative 2x. Here we get a negative 7x squared, and here we get a positive 2. Let's put this in order. It comes over here. 7x cubed. Whoops, I don't know why I put plus. That's actually a minus. 7x squared minus 2x plus 2. And that's what the original was. 7x cubed minus 7x squared minus 2x plus 2. That means this is the correct factoring of it. Okay, now we're going to go to an... Oh, wait a minute. I should have you practice one, and I have a practice one ready to go. Practice this one. 2x to the 4th minus 5x cubed minus 12x plus 30. All right, go ahead and take a few moments to do it. Pause the video. When you come back, I'll be starting again in 5 seconds video time. Okay, let's go ahead and do it. I'm going to look at these and see 2 and 5. I can't take anything out, but I can take the x cubed out. So it's x cubed, 2x. I'll do x cubed under here, just sort of keep my brain on straight about it. So it leaves a 2 and an x and just the 5 here. Okay, when I look at this one over here, I'm going to have to use the negative. And it looks like, let's see, I think 6 can go into both of these. So it's going to be a minus 6. That's going to be a 2x. Oh, I have to put minus with these because then these minuses become a plus for the 2. And this becomes a minus 5. And there we are. These two are the same. So I can take that out as a common factor. Oh, but let's check it. 2x times x cubed is 2x to the 4th power. I'm going to do negative 5 times x cubed, makes it negative 5x cubed. Then I'm going to do 2x times 6 is negative 12x. and negative 5 times negative 6 is plus 30, and that's what the original was. That was a minus there, plus 30. So that means this is the correct answer. Okay, now let's increase the difficulty, where what we're going to do is what's called solve completely, which means in this case we have to do something more. When I look at all this, I could do it the way I just did it, but it would be even more complicated. At some point I have to take out a common factor at the beginning. If you look at all these, well, they're not all divided by 10 or 2 because you have, well, maybe by 2, but I think I can up it. Can I? No, 2 goes into this, 5 doesn't, 3 doesn't. So it looks like it's 2. I can divide all of this by a 2. 30x cubed minus 100x squared minus 33x plus 220. Now, for this part in here, I can start grouping it. I'll still have to have a 2 when I get to my final answer to account for that, but this will be a little easier to work with. So when I look at these, I can divide both of these by 10 and x squared. So 10 goes into 33 times. I'll put 10x squared here, and that's 3 and an x. And over here, 10 goes into 110 times. So that's minus 10, and oh, the x squares just go away. Here, I'm going to have to do it with a negative, and that means I'll divide these. When I look, ooh, this looks like, would 11 work? Oh, I forgot, when I divided by 2, I forgot that I was supposed to put 110 here. So now I can see that I can divide both of these by an 11. And this one doesn't have an x, so I can't do the x. But I can do minus, because I have to make that plus for this one. So it's minus 11 on the outside. 33 divided by 11 is 3. 110 by 11 is 10. Have this x, and plus divided by a minus is minus 10. These two are the same. So these two get their own parentheses. 10x squared minus 11. And the 3x minus 10. See that it doesn't matter where you put that one, before or after. So that should be my answer. Let's check it. 10x squared times 3x is 30x cubed. Then I have 10x squared times negative 10 will give me 100 minus 100x squared. And 11 times 3 is minus 33x. And then 11 times 10, negative and negative makes it a positive 110. That looks nice, but that's only the second part. That's not the original. That's because this 2 has to be included also. Now, if I multiplied that 2 times all those, I would get these, and then it checks. So don't forget when you take out a common factor that you have to include that as well. Here's a practice problem to do. This is 21x cubed minus 6x squared minus 105x plus 30. Okay, go ahead and do that one yourself. Look at them first carefully and figure out what common factor can come out of all of them. If you don't do it, you can still work with this, but you'd have to take a common factor out at the end or near the end, which would also be an acceptable way to do it, but I'm going to have us do it with doing it right at the beginning. Okay, pause the video and do this problem, and in 5 seconds video time I'll start talking again. Okay, by now you've realized that all of these can be divided by 3. So I have a 7x cubed minus a 2x squared minus 35x plus a 10. So I'll put a line through here, and I guess no, I won't do the 3 yet. Instead I'll look here and see that there's an x squared that can come from both of these. So I have x squared 7x minus 2. Over here I'm going to have to make it a negative, and it looks like a negative 5 will work with both of those. So it's negative 5, this will give me a 7x, this will give me a negative 2, and they're the same. So I have x squared minus 5, and I have 7x minus 2, and then I put a 3 in front. And if you multiply this out, you will see that you will come back. If you multiply this out and then multiply by 3, you will see that you get back to that so that you can check it and be sure that it's the right one. That's the answer for that practice problem. Okay, now there is a different kind of solve completely. Let me put that paper aside. Okay, so we're going to look at right this minute now. Okay. It is going to be this kind of a problem where we're going to solve it doing the grouping, but then there's going to be a difference of 2 squares inside it. So right now I see nothing I can take out, and there's 4 of them, so I'm going to try this. I can divide x squared into both of these, and over here, it have to be a negative number. Nothing except a negative 1. So I have to take something out. It would have to be a 1, or in this case, because that's negative, it'll be a negative 1. This is an easier one. Negatives cancel. I'm going to get 4x plus 3. That means I should get 4x plus 3 when I do this one. And that does indeed give me 4x. X's go away, plus 3. That's what I get. So here I get x squared minus 1, and this common factor as 4x plus 3. This is where you need to recognize what you're looking at. This is a difference of 2 perfect squares. X squared minus 1 squared, so that's actually x minus 1, and x plus 1, and then the 4x plus 3. You are expected to recognize the things you've been learning. So whenever you see a difference of 2 squares, automatically you should be thinking of doing that. So if you did this answer, you only get partial credit. This is the correct answer, not this. This still has to be reduced. Leaving it like this and not making it this is just like leaving 4 over 8 as a fraction answer for me when you know that I never accept fractions unless they're fully reduced. So 4 over 8 has to be changed to 1/2. X squared minus 1 must be this. If it was x squared minus 4, it would have to be x minus 2 and x plus 2. If it was x squared minus 5, I'd have to see x minus 5 and x plus 5. If it was x squared minus 81, I should be seeing x minus or x plus 9 and x minus 9. It wouldn't matter which is plus and which is minus. Okay, now practice one of these. Okay, so the practice one I'd like you to look at here. Let's look at 3x cubed minus x squared minus 75x plus 25. Okay, go ahead and pause the video and do this problem. Come back to it when you're done, and I will start talking in 5 seconds video time. Alright, I am going to split this up because there's no common factor that will go into all of them. Here I can see that x squared allows me to do x squared, that's a 3x here, and a minus 1 here. Over here, I'm going to have a minus, so it looks like minus 5. No, minus 25 goes into both of these. I could do minus 5, but then I have to do another minus 5, or plus 5. So if I do minus 25, the negatives cancel. That becomes 3x. Here it's 1, but it's minus 1. So that's actually, that minus 25 needs to go here. So now I have x squared minus 25 from these, and then the 3x minus 1 as the common factor from both of those. I should have put that, could have put that in front, but it doesn't matter. And you were expected to recognize these perfect squares, so that's an x plus 5 and an x minus 5, and then 3x minus 1. So if you multiply this out, multiply this first, and when you get to this, then do this makes 3x squared, that makes a negative x squared, this is 75x, and this is a positive 25. So you are expected to recognize perfect squares. Now here is a different type of one, a combination of it. So this is probably the most complicated that we would see. Well, there is one more other thing, but we'll just go this far now. So I see first that I can take a common factor out of all of these. So I'm going to do that. 3x cubed plus 2x squared minus 3x minus 2. So I've now divided each of these by a 2. I could have made that x to the 4th, x cubed, x squared next, and I would have had a 2x out here. I'll do that some other time, maybe even on a test. So now I'm going to work with the middle part here, and I see that I can take an x squared from both of these. So I get x squared 3x plus 2. And here I see I'm going to have a negative, so it looks like the only thing I can do is a negative 1. So that's going to be 3x plus 2. Oh good, these are the same. So I have a 2, I have a 3x plus 2, and then I have this x squared minus 1. Now notice I didn't forget the 2. It's real easy to forget about it, but that's why at the end I would have checked it carefully, I would have seen it. But now I also recognize that here's perfect squares. So I'm going to have 2, 3x plus 2, x plus 1, and x minus 1 because they're 1 squared here. So it's a difference of 2 squares. So that would be the full, complete answer. That's why solving completely means go as far as you can. And even if I didn't say completely, solve means do as much as is possible from the things that you should be recognizing. Okay, practice problem. The practice problem to use is 15x cubed plus 10x squared minus 60x minus 40. So since we just did it, you should be able to expect to take out a common factor and then probably have a difference of 2 squares in there. Okay, go ahead and do that. Pause the video and come back to it when you're ready, and I'll start talking in 5 seconds. Alright, here we are. I'm going to go like this. It looks to me like for these I can do an x squared from both, but I can also do a 5 from both. So it looks like 5 and 5x squared is my common factor here. So I have a 5x squared. That makes a 3x here. And here 5 goes into that 2 times. Okay. And nothing more yet. Oh, it's a negative. So I'm going to do... well, both zeros, 10 can go into them, but it looks like 20 can actually too. So, let's see, is that a 20? No, 20 doesn't go into, right? Yeah, I think I can do a 20 in here, can't I? 20 and 20. So I'm going to have negative 20, and then I'm going to have 3x, that's plus 2. So, now I'm going to have the 3x plus 2 and the 5x squared minus 20. Oh, look, there's a common factor here. So I could have taken that out at the beginning and taken it out by 5, but here's an example of where we can do it a little later. I'm going to divide both of these by 5 and put it right in the beginning. So it's x squared minus 4. Because it's, you could do 3x plus 2, then a 5, then x squared minus 4. But putting the single number in the front is usually what we do. Oh, I recognize a difference of 2 squares. That's 2 squared. So what I really have, let's do plus, and that's a 2. I don't know why I started messing that up. But this then becomes x minus 2 and x plus 2. So it's 1, 2, 3, 4 factors for it. Okay. So 4 numbers that would together that multiply get back to this original. Now you can multiply this out, but if you were, I would recommend to multiply this first and to get x squared minus 4, then multiply these, and then multiply 5 back into them. That would be the easier way to check to make sure you get that original number. Alright, so here these two had 2 different things to do. A common factor that you could take out at the beginning or near the end, and a difference of 2 squares that had to be finished as well.